Stress strain curve. So this is actually physics, right? But our body works the same way. So up the one side is stress and across the bottom is strain. So when we put some stress on our body, it causes some strain, right? So this is the epitome of exercise. How much stress are we going to put on and how much strain is it going to cost? And it's a linear, you can see it's almost a perfect linear up to the yield point. And that's because our tissues are elastic. So our muscles and tendons all have some elasticity built into them. So if you put a stress on it, the first thing that happens is you go to the end of the elasticity. Once you get to the end of the elasticity phase, then you go into that, see how it starts to curve? That goes into what's called the plastic region. So see how it plateaus out and then you hit a failure point? The faster you put stress on, the more strain you create. So this shows why you either build up or break down. If you get past the elastic point, but not up to the top, so you bump past that yield point just a little bit, then your body will adapt. If you blow through the yield point, eventually you can get to the failure point where the tissue gives, where it ruptures. So this is when you see somebody, sports injuries are why we break down when people get hurt working out. It's because they don't understand that regardless of whether you want to believe it or not, there's physics involved in the human body. And you cannot take a tissue and load it too fast with too much stress without damaging it. So it has to be progressive increases. It doesn't matter what kind of shape you think you're in. Now our body adapts because as we exercise, our body's able to take more strain. So our tissues, the interesting part of our musculoskeletal system is it actually adapts. So where this same curve works with every tissue or everything, right? You can use t-shirts, you can use any material, you can put it in a stress strain gauge and the same curve shows up. There's an elastic phase followed by the plastic phase where you're in that it's not going to give anymore. And if it doesn't, and you keep adding stress, it'll just give. I was actually up at the Mojave the other day at the Virgin Galactic where they're building the new spaceship. And it's interesting because they're doing all this now, right? They've tested it all the different stresses that are going to be and how much strain they have a big machine that's doing it. That's just testing all the components to see how much they can take, how much stress and strain can they take. It's a give and take of knowing that they're ready for whatever happens. And our body's the same thing, except our body will adapt.
Let me ask you this, Tim. So just like an athlete get a sprained ankle, that's what has taken place?
Uh-huh.
It's just...
Because so a sprained ankle, they're running, right?
Right.
And the tibia and fibula come down, the lower leg bones, and they hook around, and it's a mortise they create around the ankle joint, or the talus. That's what gives you your flexing. So there's 3 ligaments on the outside and a great big ligament on the inside. So what happens is you run in and you step on something or step on somebody's foot, and the weight starts to go over. Well, at some point, the ligament catches. But if there's too much force, and it can't, then it pops. And there's 3 degrees of strain. So once you get into the plastic phase, grade 1 stress or strain or sprain is where you take the normal tissue and you take it past its normal length. But just you hit that plastic point, you hit the end zone, right? So that's where it should stop. But there's so much force that it continues past that a little bit. So you stretch it beyond, but nothing breaks. You just overstretched it. Low grade 2 is some of the fibers break. High grade 2, a lot of the fibers break, and a grade 3 is a complete rupture. So it's just this curve. So it's as you go up and you're hitting over that, as you go from that yield point. So it'd be like grade 1, grade 2, high grade 2, grade 3. And it's the same whether it's a ligament or a muscle or a tendon. Now, if you continue to go into that too high on the yield point up here and don't let your body recover, we get chronic inflammation, which becomes itis, which is a tendonitis, a bursitis, those kind of things. So we start to break down. And that's the warning sign that we're not fully recovering or something's wrong with the system. But again, it's the speed and the amount of the force as it's applied.